All right, so the cliffhanger was, what is Node.js as you know it today? Anything? Yeah.
Well, it's like a framework for writing JavaScript applications broadly.
Okay,
And I know, like,
that works.
Common use is like, or something you can do is like run an HTTP server.
Okay, good. Yeah, so it's a framework. It's an engine via which you can execute JavaScript code server side. This can mean the simplest of things, like writing a command line script, not in Python or Bash or Ruby or PHP, but just in JavaScript itself and executing it at a blinking command prompt. Or you can actually run it within a web server. And in fact, within Node.js itself, this framework is a whole bunch of libraries, among which are an HTTP server built in. So you can actually write a server, as we'll see in just a moment, super easily by just understanding a bit of HTTP and TCP and ports, and you can spawn a listening web server without Apache, without Microsoft's IIS, without any other software installed. You can just spawn this and listen to most any port on the system that you're allowed to. So case in point, let me go and open up this example, server0.js. So notice at the top of this file, just a bunch of uninteresting comments. And then there's a couple of representative lines of code that we'll see recurringly. So var HTTP gets require, quote unquote, HTTP. So built into Node.js's infrastructure is a whole bunch of modules, which are really just libraries. And everything is sort of namespaced with a unique identifier. Like this one is, quote unquote, HTTP. So that, like in a lot of languages like Java and C++ and C, only when you import or include, or in Node speak, require a module, does its bits and all of the memory it requires get loaded into RAM and therefore used. So you sort of load these libraries or modules on demand. This means go ahead and require for this program the HTTP library and refer to that library by way of a variable called HTTP. But this left-hand symbol could have been called anything, foo, bar, baz. It doesn't matter. So unlike C++ and Java and C, where when you require or import a library, it just sort of becomes globally accessible, Node.js modules are more tightly namespaced so that that functionality is only accessible at the moment by way of this variable name. You can't just start typing methods that exist in it right away, which is probably good because then your namespace doesn't get nearly as cluttered as in a lot of languages. All right, so now as the comment suggests, creating an HTTP server, as Jonathan proposed was possible, is literally as simple as calling the create server method inside of the HTTP module. So this is returning me a reference to some kind of web server akin to Apache. Not necessarily as heavyweight. This one's a little simpler. And now I have to simply do a few things. So first, let me scroll down to the bottom here and skip the handler method for a moment. And notice this line of code, server.on, which is essentially means server listen, like in jQuery code. Listen for an event called request. And just take a guess. What should I do when a request event fires in the server? Yeah. Call the function handler. So literally execute the code that's referenced by this variable. And actually not a variable, it's a symbol here. What is that symbol referring to? Well, this named function up here. And handler apparently takes 2 arguments. Why 2? Well, if you just read the Node documentation for this particular module, you will be told that the handler that will be invoked will be passed at least 2 arguments. A reference to the request. And inside of the request, we literally mean HTTP requests. So all those HTTP headers that you might recall from the beginning of the semester or some prior class or experience, like the get line and the host line and the user agent line, all of that is encapsulated and more inside of this request object. And the response object is sort of for outbound data. So you have a reference to an object that's going to allow you to send information back to the browser by calling methods on that latter argument called res for response. But these could be called foo or bar. These are just conventions. So now what do I do? Well, it appears that inside of this super simple web server that I'm implementing, I'm going to do the following. I'm going to write an HTTP header with status code 200, 200 meaning OK, all is well. And then I'm going to pass in apparently, what's the data type of the second argument to write head? It's an object with how many keys and values? Just one of each, right? One key value pair. So quote unquote content type. And the only reason I'm quoting it here is because the hyphen might be conflated for a minus sign or something like that. So I have to quote it here, single or double quotes. But again, common paradigm in JavaScript code is often single quotes these days, colon, and then the value. So this is just a so-called MIME type. This is an HTTP header that's literally going to be content-type : text/plain that's going to be sent from the server to the browser so that the browser knows whether to render this as raw text or HTML or as an image or a movie or a flash file or anything else. Now, what do I actually want to send in the body of the page? Well, just by reading the documentation for the response object inside of this library, I see that there's a write method, and that takes a string, maybe other things, but minimally a string, and the string is what's spit out to the browser. In this case, it's super simple. It's hello world, but it could be open bracket, HTML, close bracket, open bracket head, close bracket, and so forth. This could be raw HTML, but we're keeping the example simple by just spitting out the simplest of MIME types, which is arguably text/plain. And then response.end just means close the connection and send everything I've sort of buffered inside of this object back to the browser. I'm done. All right. So the last thing I'm doing down here, and this is somewhat arbitrary and meant to be cool, is I'm telling the server finally to listen on a certain TCP, by default, port. Recall from the beginning of class that services are typically uniquely identified by numbers. 80 is the web, 443 is HTTP-based websites, 22 is SSH, 21 is FTP, and 1337 is just arbitrary, but it's higher than 1024, which means on most systems I can use it without needing super user privileges. So it's just convenient. But 8080 is a common one, 8088, really anything big in the thousands is common, but this is just more elite. All right, so what happens when I actually run this? Well, I don't just visit the page in a browser. This file is called server-0.js because, again, Apache is now out of the picture for the latter half of the course. If I want a web server, I need to write and then run this web server. But it turns out that JavaScript, both on the client side and the server side, is an interpreted language. So all I need is an interpreter. So it suffices to run node and then server0.js. I may or may not see some output, depending on what libraries I've included. Nothing seems to be happening. But let me go to a browser, and let me go to the same IP address of my CS50 appliance. But this could just as well be my Mac or my PC. And then hit Enter. And that actually looks like Apache. That's like the directory listing we looked at in the first half. So what did I do wrong? Yeah. Exactly, right? So Apache is still listening on the default port 80. Even though I could change that, I could turn it off altogether, but it's still running. But these guys can certainly coexist. I simply have to put :1337 and then maybe or maybe not a slash at the end to access this port that this server is running on. And now I see that hello world is returned. And I can hit reload as many times as I want. It's still serving up a page. Indeed, if I open up Chrome's inspector, go to network, and then reload the whole page, notice that indeed this was the request that was sent. If I look at the raw source, notice my browser sent all of those things, and then the response from the server was super simple. There's the 200, if it's not too low on the screen. There's the content type. And then Node.js sort of automatically for me added the date and all of the other stuff that browsers typically expect. So let's just see a little sanity check. Let me go back to the code in server0.js. And let me, every time I go into the handler, let me just say console log, we had a visitor. I don't need to recompile or anything like that. It's an interpreted language. So now let me go back to the page, reload 1, 2, 3 times, go back to my window, and now I see this. Well, that's strange. I see 6 lines. Interesting web trivia. Why did I get 6 requests, not 3? Yeah. Yeah, so as you may know, the little stupid icon in the top of the browser bar that a lot of websites use might be a Harvard crest, it might be a company logo or anything like that. So browsers these days sort of presumptuously make an additional HTTP request to almost every website that you visit, checking if there is by default a file called favicon.ico in the same directory as the file you requested, and if so, it puts the icon there. So all we're seeing is exactly that. And in fact, let's see if we can see this. Rather than type out just we had a visitor, let me go ahead and output. And I only know this from looking at the documentation. There's a property inside of the request object called URL, which happens to be the path that was requested in the actual URL. So if I restart the server simply by rerunning node on server0.js and now do this 1, 2, 3, and go back here. There it is. Slash is what I, the human, requested, and favicon.ico is what the browser is presumptuously requesting. But the point isn't so much favicon stuff, but how the server is operating. Yeah?
Why does it have to be a separate request?
Why does it have to? By nature of how HTTP works. So HTTP can only request one file at a time. Browsers can be smart these days and keep the TCP connection open. If you took CS143, you're generally familiar with networking, so you can get efficiency gains by keeping the network socket open and making multiple HTTP requests serially over it, but they're one file per request. So if you visit something like, I mean, we can go to most any website. If you go to, let's pull up Chrome's inspector here, make it fill most of the page, go to the network tab, and go to www.cnn.com. And when you visit cnn.com, its homepage, your browser, rather atrociously, makes, still counting, okay, at least 289 HTTP requests again and again. And this is why when you visit particularly bloated websites, they're slow to load because of all of the assets they're loading. So it looks like 298. There might be some Ajax going on at this point, or some of the assets are just slow. So each of those is an individual request going back and forth, back and forth. And that's why earlier, even though we sort of talked about it somewhat fancifully, where you put the script tag absolutely makes a difference when you start to have a lot of traffic and a lot of files being requested. And each of these represents probably an image, a media file, a JavaScript file, CSS file, or the like. So we're already up to some 4 megabytes just to look at the day's news. Good question. All right. So what are some of the upsides, though, right? We know how to make web pages already with PHP, and many of you came into the class knowing Django and Python or Rails with Ruby. So why do we need yet another language and infrastructure? What is Node.js particularly good at, if you know? Something? No? Yeah? So relaying messages. So that's true, and it's true for a more technical reason in that Node.js and really JavaScript is particularly well suited to asynchronous code, whereby you create the illusion of doing multiple things at once, even though they're really happening serially. Indeed, in most cases, JavaScript, both client-side and server-side, is single-threaded, which if you take in 161 or even 61, means that the program, Node, the interpreter, can literally only do one thing at once. But this isn't great for something like a web server, where you might have dozens or hundreds or maybe even thousands of users all trying to access your web page at the very same time. And yet that suggests that handling them one after the other, especially if some of those requests, as we saw on CNN, might require serving up 300 files before you even get to the next user who wants to see the day's news. Node.js is better suited for environments like that, because what happens is any slow-running process, like reading a file from disk, or querying a database, or talking to some other network server, that tends to have latency, right? If you did take 61 or 161 especially, all of these sort of peripheral services tend to be much slower than doing anything inside of the same RAM and the same CPU that, say, in this case, the server is actually running. But what's nice about Node.js is that you can essentially, and JavaScript more generally, is that you can do something and then say, this is going to take me a few milliseconds or even a few seconds. Let me sort of fork that off, but it's not a true process. And then when it's done doing that slow running process, like grabbing rows from a database or reading a file .html from disk, it'll get back to me rather than me having to wait for it. So to make this more clear, this is my means of making this more familiar. All right, so this is the Shake Shack in the square. This is sort of a common paradigm for explaining asynchronicity. This is actually a good example because Shake Shack and Tasty Burger are remarkably slow for what they do. But the point is, they're really good at taking orders and taking your money, after which you wait for your food. So this is actually a better design than the alternative, because suppose you walked into a store like this and you got to the front of the line and you placed your order and you want a burger. As best I can tell, it takes at least 5 or more minutes to actually get a burger. So it would be kind of a bad business model if while you're waiting for your burger, Alice and Bob and Charlie and everyone else is queuing behind you and you are literally blocking the line waiting for your food. So obviously Shake Shack and other fast food places don't do this. They do something like this. They give you a buzzer and they sort of send you on your way. and they call you back by making this little thing vibrate or flash to get your attention. So this is literally what something like Node.js does. If Node.js, or JavaScript more generally, is being used, and the programmer is smart enough to realize, you know what, whatever I need to do right here could take some number of milliseconds or seconds, you know what, let me go ahead and not call it synchronously, that is, guy blocking everyone else in line, let me go ahead and sort of step aside and simply call myself back when that long-running operation is complete. And callback, of course, is alluding, in this case, to a callback function, a reference to a chunk of code that will get executed when your burger is ready, much like this thing has some kind of functionality built in that it starts vibrating or buzzing when it's time for you to be called back to the front of the line. So what does this mean in real terms? Well, we have to work our way up. So let me go ahead and do this first. In server1.js, let me first simplify the code so we can take baby steps toward a more compelling problem. This is the exact same program that I wrote before, but what has been changed? There's sort of a slight syntactic difference between this and version 0 a moment ago. What jumps out at you if you recall? Yeah, Cynthia. Yeah, so now we have a lambda function being passed in. We've gotten rid of the sort of uselessly named handler function. Useless only in that if I'm only calling it in one place, I don't really need to waste time giving it a name and making it harder to read the code top to bottom. So let's just declare it inline as an anonymous function. And I'm doing two other things. I'm making better use of dot notation. So like in jQuery, a lot of Node methods can be chained together so that once you're done calling something, you don't have to wait till a new line and call another method. You can just chain them together. And so in this way, we can really tighten this up. So this is literally a web server in 5 lines of code total, unlike what you might normally have to do to set something up. If I go into server 2 now, let's do this. In server 2, actually, let's come back to that, server 2. Let's now open up async0.js and address that problem at hand. So first, let's go ahead and open up async0.js in a browser. So async0, let me go back to the browser, hit reload. And now this is some kind of error message. Indeed, I'm seeing a 500 in Chrome's inspector. But let me more precisely request hello.txt. OK, so this seems to work. So async0.js doesn't seem to serve up something for slash. It has no default file support. But if I explicitly request hello.txt, that seems to be supported. Why is that? Well, what I've gone here and done is implemented a super simple web server that demonstrates where asynchronicity can be useful. And that is implemented as follows. First, I'm using the HTTP module again, but also FS, which probably stands for, in general, in CS, file system. OK, file system. Henceforth, FS file system. All right, so what does this give me? Functionality related to files, like getting paths, opening files, writing directories, reading directories, and all of that kind of stuff. So now notice this code is the same as before. Create the server, passing in an anonymous function. This is kind of arbitrary. This is not a very secure web server. In fact, you could access most any file on my hard drive or on the server's hard drive by executing this code, because I'm just blindly assuming that I'm going to grab whatever the user requested in the URL, and I'm going to prefix it with dot so that I'm marginally being safe by saying whatever file they can request has to at least start in the current directory. Of course, there's a threat here, because if they instead include what in their path, they can kind of work around that too. Dot dot, right? So if the user just puts dot dot in the URL, in theory, they could start getting my Etsy password file. So this is not meant to be secure. It's meant to be simple. So here I have a variable, which is the concatenation of dot, which is present directory, and the request URL, which we saw before, is like slash or slash hello.txt. So now it gets a little more interesting. First, notice the bottom. I'm listening on the same elite port as before. So the real interesting work is inside of here. Every time a request comes in, by nature of this code, what am I doing? I'm calling file system's read file method, passing in the path that I want to read. And now this is what's interesting here. This is, by implementation, an asynchronous method. You cannot get a return value from read file. In fact, notice, there is no left-hand expression to the left of read file. It does not return a value. Rather, it calls a callback function when it is ready to give you back an answer. So again, to be clear, whereas in yesteryear, in many programming languages, if you wanted to read a file, case in point, PHP, file underscore get underscore contents, you have a left-hand expression, an L value after before the equal sign. That means you're assigning to that variable the return value of that function. You can do that in Node.js, but you typically have to call explicitly synchronous versions of functions, like I think it's read sync file or sync read file. I forget how they named it. And that would give you a return value. But if that file is on some remote file system or disk is just naturally slow, it could take 10 milliseconds or 2 seconds for that file to actually come back. Meanwhile, no other web visitors are being serviced by your website. You're blocking. That's what's called blocking I/O, input-output. So here, this is much smarter, because what Node.js is going to do upon interpreting this is the following. It's going to call the readFile method, try to open up the file who's got a path specified by the value p, and then if and when it's ready to give you back the contents of the file p, it will call a function whose signature is, by convention, the following. 2 arguments, the first of which is maybe an error object, capital E. It's an object called error, or null if there's no such error. And the second argument, take a guess, is going to be what? It's called data, obviously, but what is data more concretely? The contents of hello.txt in the example I pulled up in my browser a moment ago. So in other words, read file and many Node.js functions like it do not return values. They call callbacks and pass to those callbacks what would have been traditionally the return value. The upside of this approach is that you might call read file at t0. The callback function might not be called 1 tick later, so to speak, at t1. It might be called at t1000, 1,000 ticks later. But the point is that the rest of the code in this file, if any, would immediately be executed while Node.js and while the file system figures out how to read that file and get it back to you. So you create effectively the illusion of parallelism while letting slower running processes not block the important stuff, the part that's servicing users. So how do we handle this? This is a very common Node.js paradigm, and there's ways to simplify this, as we'll see before long. I first check if error is not null. So if it's not false, then there was an error. I don't know what that is. Maybe the file doesn't exist. I didn't have permissions. The path name is wrong. Any number of things could go wrong. For now, I'm going to arbitrarily return a 500, which is internal server error. Something went wrong. I don't really care to diagnose it, so let's just tell the user it's broken. And then I'm going to do response.end, and this is shorthand notation. Recall that last time I did response.write, and then I did response.end. If you only want to send one line of output, you can just do it all at once with response.end with an argument. And that's going to send whatever the error message is inside of this object to the browser. It was pretty arcane. Recall a moment ago, I have no idea what this meant at first glance, but when I requested a file that didn't exist, whoops, we need to run the server again. When I requested a file that didn't exist, E is dir, so something about it being directory. If I do some random string there, apparently that means the file doesn't even exist. And that's because my code is simply saying to write out whatever the raw error message is. So not very user-friendly, but at least I'm handling it. Else, if it wasn't an error, what am I doing? Same thing as before. Spit out a 200 OK, a plain, text plain MIME type, and then spit out the data. And that's why I'm getting the contents of hello.txt, which, just to confirm, if I look at hello.txt, it's literally just hello world. And if I change this, hello world, save the file, rerun the server, reload the page, now I get that version. So I've really just re-implemented a web server as has existed for many years, but using Node.js. But we can do this even more cleanly. Let me open up async1.js. Now notice I'm adding another module this time, apparently the path module. Now this is a good opportunity to look at what the documentation looks like. Node.js's documentation, like PHP, I think, is actually pretty good and straightforward. If I go to Node.js and Google and search for Node.js path, what you'll see usually is a direct link to a URL that I put up here a moment ago. So /API is the official place to go for documentation. And what you'll see at the top of Node's official documentation is all of the methods and or properties inside of this particular module, one of which is called join. And join is just a helper function that's going to allow me to not bother with all of the pluses. And it has the added bonus, as you'll see from the docs, is it also normalizes the resulting path. So if the user or you have dots or dot dots or any combination of those kinds of relative paths, among the upsides of the join method is that it's going to clean all of that up and give you a canonical path without any of those dots or dot dots. So it's a good thing in general for security, at least if you're checking the return value, which I'm not in this particular simple case. But I did want to use it. So I now create the path a little more programmatically with path.join instead of raw concatenation. So that's a little cleaner than before. And now notice I'm being a little more intelligent. Rather than just blindly try to read the file, I'm going to actually call fs.stat. So if you're familiar with low-level C functions in C, or even PHP, a lot of libraries have these functions. Stat returns essentially statistics on a file, the file size, the permissions, the name, and things like that, and also implicitly if the file exists or not, and if it's a file or directory or symbolic link or something else. So now notice I'm calling fs.stat, and then apparently, according to the documentation, I should get back an error object or null followed by a stats object. Well, let's check this. Node.js fs. Here's the file system documentation. Let me look for stats. There's a lot more functions here. Whoops, that's stat sync. fs.stat. So here, it's an asynchronous stat, open paren 2, close paren. That's meaning, if you remember from man pages, chapter 2 of a man page, that means this is literally just a node implementation of the low-level system function stat. So the callback gets two arguments, error and stats, where stats is an fs_stats object. So let's see what this object is supposed to look like. Let's click the hyperlink, and I see that the stats object contains apparently some helper method. IsFile, isDirectory, is a bunch of other things. It's the isFile that I care about in this particular case. So here I go. If there was an error, then let me just bail this time and assume if there's an error, it was probably a 404, file not found. Could be something else, but I'm being a little lazy here just to focus on the more interesting details. But for the user's purposes, file's not found if there was any error statting the file. Otherwise, let me check if the file is indeed an actual file. So if it's not a file, it exists. There's something there, but it's probably a directory or maybe a symbolic link or something else that's funky on the file system. Either way, the user shouldn't see it. So now I'm just going to spit out, conventionally, unauthorized, 403. But again, just a convention. I could have used something else in theory. And then lastly, let me try to read the file. So let me scroll down. And now notice this is where the code can get a little messy. Notice that I'm calling fs_readFile, passing in the same path, same callback as last time, so the previous version. And then if I don't find it, I spit out a 500. And if I do find it, what line are we going to see here? We're going to see the fs write header 200 probably, and a response.end sending the actual data. But notice this, and this isn't demonstrative of the worst case scenario, but I have this stat call here, then I have some stuff, then I have another asynchronous call here, so more indentation. So just kind of extrapolate, if you could, from here. What problem tends to arise with a language like JavaScript in this environment where you don't have return values, but rather you have these callbacks? And of course, this is just a stylistic thing, the fact that I keep indenting. But take this to the logical next step. Suppose there were 1 or 2 or 3 other functions that I needed to execute that were by nature asynchronous. And therefore, you just kind of keep indenting to handle them, to handle them, to handle them. You get sort of callback hell, as people call it, where your code starts to get very wide and, frankly, really hard to read. As it is, I can sort of barely tell that this is sort of a flow that has this sort of stylistically angled thing going on here. So this isn't ideal because this can very quickly become unwieldy. Even though 2 asynchronous calls, not such a big deal. So we could avoid this, right? You may have glimpsed that I misclicked a moment ago. In the documentation, you know, it looks like there's stat sync. And stat sync does not take a callback as an argument. It takes just the path because it apparently does what? It returns an instance of fs_stats. So this might be your first instinct, right? Especially if callback functions and these asynchronicity is a little new to you. Frankly, the easiest approach is probably just avoid the problem altogether. Go back to sort of CS101 style programming where you call function or a method, returns a value. Call function, returns a value. Function returns a value. And I could use, therefore, fs.statsync, which is literally the same, but it's a synchronous version, which means it returns a value. It doesn't pass a value to a callback. But why would that probably be a suboptimal workaround to resort to synchronous functions? Yeah. Exactly. It takes a long time. You're just slowing everything down because much like Shake Shack or Tasty Burger, if they got rid of those buzzers and made you, the customer, stand at the front of line until your food is ready before even taking the order of the person behind you, obviously throughput slows down, people start leaving, you sort of drop packets. You can make any number of analogies here, but in short, it's probably not a good thing for business or for the server. So asynchronous code is typically good, at least in this case, but it definitely starts to cause some angst. And in fact, I dare say when first writing this stuff, it'll take a little bit of getting used to. So let's start to equip you with some libraries and techniques to make this a little easier. So one of the most common libraries, or popular libraries these days, is one called async.js. And like a lot of Node.js libraries or modules, these are all open source. They almost all live in GitHub repositories, which has kind of become the de facto place to store these things. And then there's a whole infrastructure for installing these things called NPM, Node Package Manager, which if you're familiar with Ubuntu is kind of like apt or apt-get. If you're familiar with Red Hat and Fedora, as in the appliance, it's like Yum, but it's a package manager just for this particular environment. So we can download and install things like the async library, and also another one called the underscore library or module. But these thus far, FS, HTTP, path, those are all come built into Node. So if we go to the API docs, you'll actually see that built into Node, you get for free a whole bunch of modules, but plenty of nice people on the internet have made dozens, if not hundreds, of other libraries to do things better or differently. So let's take a look at how this library works. So most of this code is identical for the moment. I have a path being created up top, and now I'm calling async.series. So the async library is just a library that allows you to pass in arrays, typically, of functions to get called one after the other, just to kind of avoid that indentation issue and really just the mental angst that will invariably arise, at least when you first dive into this on your own, with programming asynchronously. As an aside, if you have taken 161 and you've dealt with locks and race conditions and all of that, asynchronous code in an environment like Node.js is actually much, much simpler, arguably, than actually writing multi-threaded code. Anytime you have multi-threaded code, you do have race conditions. You have to worry about two threads contending for the same resources, disk or memory. The beauty of JavaScript and Node.js is there's literally only one thread, which means the browser or the server can only do one thing at once. It's just up to you, the programmer, to keep a mental model for how you sort of queue things and figure out how to order your code. But you never have to worry about race conditions in quite the same way, at least with raw code like this. So it's a little hard to grok here, but so let me open up the docs for just a moment. The async.js library, which similarly is very Googleable, lives in a GitHub repo like a lot of them. Don't think it's sketchy. It's not. Let me scroll down to the README here. So the async library provides a whole bunch of methods inside of it. For instance, there's a method called each, which if I click this just to see its docs for a moment, this is a function or a method that allows you to do something like a for each, but in parallel. They're all going to happen potentially in parallel, and the method each is only going to return to you when all of the iterations are complete. So maybe they happen one after the other. Ideally, they happen essentially in parallel, but the method doesn't call you back, doesn't buzz your buzzer until all of the elements you have iterated over have completed. So it's just a nice way of avoiding using a simple for loop, but actually doing something asynchronously. But now, more directly related to this example, notice there's this series method. And let me just pull up a simple canonical example. So the async library's series method takes in, as implied by the square brackets, an array. What are the data types of the elements in this array based on this simple example? This is an array of functions. So in C, you would call them function pointers. In JavaScript, they're more properly references to functions or anonymous functions. And this just means arrays, of course, are ordered from 0 on up. So they maintain an order, which is good for a series. Series, of course, means do something in order, not in parallel. So this just means that this function will get executed, then this one, then this one, then this one, then this one, however many there are, until finally the optional callback is called. So notice the paradigm here. And even though this is one guy's library, it's representative of a very common JavaScript paradigm of, again, using callbacks. So notice what you do here. in the first function being passed in via this array, you define an anonymous function, just with function. But notice that apparently, according to this documentation, that anonymous function should take an argument, callback. That is going to be a pointer or a reference to a function that you should call when your code is ready to return a value. So again, unlike typical procedural programming where you're used to returning values immediately, the one difference with using a library like this, and asynchronous programming more generally, is when you are ready to return a value from a database, from a file, from an arithmetic expression, it's up to you to call the callback function. And the nice thing about this library, if we read the docs more carefully, is that if and only if all of the callbacks are called without an error object, will the whole thing succeed. So in other words, if there are 10 anonymous functions in this array, therefore in this series, only if all of them succeed will the final optional callback be considered successful. If any one of them fails, every function after it will not even be executed. So it's a nice way of sort of having a daisy chain that aborts prematurely if something goes wrong. So to see this in context, here's how we might re-implement that previous program. I get the path as before, so this is the easy part. I copy-paste the skeleton code from the documentation there, async.series, open paren, open square bracket. And now notice I have one function and the beginning of a second. We'll see where we go from this. And now notice it's a little complex at first, but focus just on it line by line. fs.stat means get the statistics or whatnot of that path. Call this callback when ready. This code is the same as before. If there's an error, there's one difference now. Again, the very common paradigm in Node.js programming is if something goes wrong and a callback needs to know that, by convention, the first argument to a callback is going to be null if all is well, or a reference to an error object, capital E. It's like an error class that exists globally, but more on that some other time. So by doing this, if there's an error, what's the implication? Well, based on what I said the series does, is if anything goes wrong, we just kind of want to abort the whole series of anonymous function calls. So it suffices for me to just return callback passing in the error object. Because if stat gave me back an error, I could create a new error object of my own, but I don't really care to. I just want to pass whatever the error is that actually happened, so I can pass it to this callback. And just to be clear, the return isn't strictly necessary. I essentially want to do this, but I want to now do return so that no more code here executes. So again, another common convention in JavaScript, even though you're not returning a value per se, you want to pass the value to the callback function, but then you want to stop execution of the function you're in. The trivial way to do this is just to call return here. But there's nothing wrong with just doing return callback error, even though it's going to return an undefined value. Right? This does not return a value, most likely. All I care about is aborting further execution. So my conflation of these two lines is just a stylistic convention, just to have the number of lines of code I just wrote from 2 to 1. So what else? If there's not an error, actually, to be clear, I could also avoid that by doing if, else. But again, another common paradigm is check for your errors up top and then just return rather than continue to indent your code with else's and else's and else's. So if it's not a file, now, I want to handle this a little specially. So here, like in Java or C++ or a few other languages, here's how I can instantiate an object of type error, passing in a default message of not a file. And this is just somewhat arbitrary, but I'm signaling an error of my own. And what does this last line presumably signify? All is well. If you pass in null for the error parameter, that just means by convention all is well. So that means what will happen logically? If null is passed to the callback, that means this anonymous function has succeeded, so to speak. So what should the series method proceed to now do, based on my verbal definition earlier? Move on to the next one. Right? If it had returned a non-null value, it would just abort and no more anonymous functions would get called. But because it hasn't, then this will get called next. So the logic in here is pretty much the same as before, and we'll see how to clean this up further in a moment. I realize this is kind of a lot to absorb, all verbally and visually. But now notice the second anonymous function that I want to execute in series is to try to read the file. Call this callback when you're ready. If there's an error, just signal it by way of the callback so that the rest of this stuff aborts. else return null. But why am I passing in 2 arguments? Well, this time, if I read the file and get it back as a variable called data, I want to not only signify all is well by returning null for the first argument, I want to return the actual data as the second argument, because if I read further in the documentation, notice this last chunk of code, square bracket means that's the end of the series. There were only 2 anonymous functions in this series. If there was an error here, then I know that one of the links in this chain, so to speak, failed. So in other words, this error is going to be an error object that is not null if any of these guys failed. And if that's the case, I'm just going to bail out, and I'm going to say 400, which means request failed. It's a very generic error message. And then I'm going to print out the error message. So I'm not bothering to be super anal this time. I'm not going to distinguish between 500 and 404 and 403. I'm just going to kind of blindly wave my hand and say something went wrong. But if nothing did go wrong, I'm going to send this, response.end, passing this data. Now, this looks a little cryptic. But again, if I read the documentation, the second argument to this final callback, the guy that's only executed once the series is done executing, or a portion thereof, this is going to be an array of all of the second arguments that were passed to the callback. Now, it turns out that the only link in this series that actually returned a second argument is this one here. So I'm going to sort of, on a leap of faith, simply use, suppose for the moment that last is a method that gives you the last element of an array. Because this array that's being passed to me has 2 indices, 0 and 1. It's just 0 has no value because this guy returns, does not pass in a second argument. But this guy does. So results bracket 0 is nothing. Results bracket 1 contains what? If you've been following along up to this point. The file, the hello world contents, presumably. So that's how I actually print it. And let me finish one detail here. If I do this sort of old school, if I want to get at the last element, I could do results bracket results.length -1. That's sort of the old school way of accessing the last element in a 0-indexed array. But as an aside, recall that I had this library up here, underscore, which by convention is just called literally an underscore character, which is not special. It just looks cool, like $sign does for jQuery. This is just a helper method, underscore.last, that does exactly the same thing. And if you've never used it before, underscore JS, both for client-side coding and server-side, is a wonderfully useful library that, as many people describe it, like jQuery, contains all of the methods people wish came with JavaScript itself. Okay.
So, like, for each of the anonymous functions in the series, you have like callback as an argument.
Yes.
And, like, so when do you actually like push that in, and like, what does it mean when you just have like callback and then you like put like null?
Okay. Good question. So let me pull up the async man page here, or the documentation on GitHub. So this is the canonical structure. If you're using this particular method series, there's 2 big parts to it. One is an array of anonymous functions, and 2 is a final callback function that's actually executed at the very end of the series. Now, if we zoom in a little closer on the first of those big things, the array of anonymous functions, by requirement of this guy's documentation, has to be an anonymous function that takes in one argument called callback, or foo or bar. Doesn't matter, but he's calling it callback. And this is sort of your buzzer that Shake Shack hands you. This is the means by which you can return a value to the customer. Because you can't just do literally return. You have to do it by way of this callback, because if inside of these functions is some slow running code, like query a database, read a file from the file system, you don't want to wait there and block everyone else. You want to call the callback. So this is literally the name of an argument. But like in C, you have function pointers. In Java, you have references to methods. And same here in JavaScript. This is a variable, but its type is function. So simply by writing its name, whether callback or foo or bar, then open paren, close paren, you're executing that on that function and passing in null, which means no error, and 1, which means this is the data that I want to pass in. And then the second chunk, to be clear, this is another callback. And it's not called callback. It's just conceptually is a callback method function, because it is called, by definition of this author's library, when the entire series has completed or a subset thereof, if an error has happened sooner. So name of callback function, calling callback function. Name of callback function, calling callback function, different callback function altogether.
We never have to like define callback.
No, because this guy will pass into your array of anonymous functions a pointer to the code he wants to execute.
Okay.
Exactly. All right, so please say that the code gets a little simpler. So it can, and if you're like me, take comfort in at least knowing it takes a while to get used to this. But we can clean this up a little bit. Not to throw too much at you, but here's another variation. And it's using another method in the same library called waterfall, the upside of which is unlike series, where each of those anonymous functions executed essentially independently of each of the others. Waterfall, like the name suggests, allows the uppermost functions to kind of pass in values to the lower functions, sort of like a cascade of water. So the upside of this is that I can kind of use this to my advantage. In async.waterfall, notice the following. I can just call fs.stat, passing in the path that I want to get statistics on. And then remember before I had an anonymous function that had 2 arguments, error, comma, results. And then I called the callback function manually. In other words, just to be clear, recall that earlier in async2, I did all of this nasty work. I called fstat, passed in p, declared my own anonymous function. I then checked if error is non-null. Then I did this, else I did that. The whole beauty of following conventions, like in Node.js, is that callback functions in general are meant to take at least one argument, an error object, followed by 0 or more useful values. So notice the paradigm here. This callback function I'm declaring follows exactly the paradigm that this guy's async library does, which is to say this. Why am I implementing my own callback method when the author of this library is literally handing me on a platter, so to speak, a callback function I can use? So I can just pass in the reference he's given me so that immediately my several lines of code become one line of code. Now, where do we go with this? The next function that I want to execute, the next anonymous function in this array of functions, does the following. Notice first, stats is the first argument. So something has changed already. Now, this guy who wrote the library, and I'm saying guy because it is a guy, this guy who wrote this library is documentation guarantees that if this function here passes me back an error object, or null, followed by a comma-separated list of other values, he will make sure that those other values are handed to this anonymous function in order from left to right. And what used to be just a callback function alone simply becomes the last such argument. Now, I don't know who I'm focusing on, just you now, but now, what's the takeaway here? So we know from the documentation, or the prior couple of examples, that fstat ultimately expects a callback with 2 arguments. The error object, which is an error object or null, followed by a reference to the stats object. So if I think about that, error object, comma, stats object, that fits in the paradigm of this person's library. So I can simply say, because I know the second argument that's going to be passed by fstat to the callback is error, comma, stats, by definition of this library, I can put the second argument's name here, or whatever. I can rename it if I want, followed by the callback here. So I can pass one value from here to here. Now, all of this code, though admittedly somewhat cryptic, is at least copy-paste for the most part from before. The only difference is, notice here, I'm declaring an error object, and now I want to get a little fancier. I actually want to know what the error was, so I'm going to tuck inside of this object a property arbitrarily called code, so that I know that this is not a file, that should be unauthorized, it's an HTTP 403. Let me remember that before I pass the error object to the callback. And then lastly, try to read file. So in this case, the waterfall, I've broken the code from 2 big steps into 3 smaller steps. Notice the beauty here. I can call fs.readFile, passing in the path. And then the hard part mentally is that I just pass in the guy's callback. The thing he's handing me, I'm going to pass to fs.readFile. Because we're all adhering to these same conventions. First argument to a callback is an error object or null, followed by a comma-separated list of useful stuff. So what that means now, and if I read the documentation, I'll know this, the very last callback, this guy here, outside of the square brackets, is going to be passed an error object or null, which I should check for as always with this code here. And then by definition of this method in the guy's documentation, the last value returned from the last method in my anonymous array, of my array of anonymous functions. So what does read file return? And I'm using return loosely now. I mean, what does read file pass as arguments to the callback method it's handed? 2 arguments. First is an error object or null. That's almost always going to be the answer. And the second thing is going to be what for read file? The contents of the file, data as we called it earlier. So by simply declaring error comma result, I'm check for error. This is sort of boring now. Else I do response.end, passing in that result. This will undoubtedly not sink in perfectly until you actually write it yourself. But for now, take away at least the fact that there is apparently this common paradigm whereby if we and authors of libraries all sort of stick with this convention of callback methods, and the first argument is an error object or null, and the second and third and fourth objects are things we care about, and we sort of follow rules in documentation, we started with code that honestly is pretty ugly. And even though the most recent example is frankly kind of hard to wrap your mind around, it's at least visually looks like it's much tighter. And once you get comfortable with it, it's so much easier and so much less prone to bugs than that previous example. So let me demonstrate one last thing here. This is version 3. No, let's leave this one alone. Let me go into a couple of other last things as teasers. All right, so in server 2. OK, first, any questions? I know this is a lot, but you wanted more instruction, so. You didn't say good instruction necessarily. Yeah?
So if it's single thread, I'm just like out of curiosity, is it like simulating the multi-threadedness by going back and forth between the stuff that's taking a long time and the new request?
Correct. You're essentially leaving it to the operating system to figure out how to juggle all of these balls at once, reading from a file, reading from a database, and it's the JavaScript server itself that's single-threaded. And essentially, and actually there's one picture I didn't throw up, and it's not necessarily all that enlightening, but maybe we'll give you a mental model. JavaScript itself, and Node in particular, has this so-called event loop, whereby you can think of Node.js, the program, as literally like an infinite loop. It's just a while loop, waiting and waiting and waiting, looking for tasks to complete. And a task might be, go fetch something from a database, or here's a value from the database, or go get this file from disk, or here's a request from a user. Any sort of event. Just like the browser is event-driven, so is the server-side event-driven. And any of those things constitute events. So someone in Node.js just wrote an infinite loop, a big while loop waiting for stuff to happen. And as stuff does happen, it ends up in a queue. Right? Certainly, a database might return a value, and a file system, the operating system, might return a value at roughly the same time, but there's probably going to be some ordering to them. And Node.js is going to have essentially a queue, like a big array or a vector, some data structure that buffers all of those things, because it can literally only handle one of them at a time. So when you, the developer, writing asynchronous JavaScript code using asynchronous function, you're allowing this so-called event loop to go to the next tick, right? So long as you immediately return, as all of these asynchronous methods do, like read file and stat, they return immediately because the callback eventually gets back. As soon as you return, that means someone else can get popped off the stack here, or they can get popped off the front of the queue here. And so there is, in fact, this serialization of everything that's happening, even though all this stuff can be happening in parallel on a multi-threaded system. But Node.js itself and the server we're running is one thread. And the downside of that is that you don't necessarily max out your computer's capabilities, especially if you have a 16-core or even a 2-core computer and you're just running one instance of Node. But if you've, again, taken something like 161, you avoid a huge nightmare of headaches when it comes to race conditions and locks and semaphores and writing truly multi-threaded code. So upsides and downsides. OK, so back to the code here. Let me propose that we start to simplify things a little bit. We saw server 1 a little bit ago, which looked like this. So that's arguably pretty simple. But just like in the world of PHP, there are frameworks like Laravel, and there's things like Rails and Django. Same thing in the Node.js world. And we'll spend more time on this on Wednesday and in the next project. But if I go into a server 2 directory, notice a couple of paradigms here. So this is going to be an equivalent example, but it's using a framework called Express.js, which is free open source software like Rails and Django, like Laravel, that's just ultimately going to be unappreciated today because we've been writing such simple examples. But trust us, this will very quickly become your friend because it will save you a lot of tedious code. And a common paradigm for an Express.js application is to have an app.js or a server.js file, which contains the logic of your program, or at least the entry point. You can have multiple files. A node module subdirectory, which has libraries that you've downloaded like async and Express itself and others. And then package.json. Package.json looks like this, and you can create it manually or tools create it for you. And it's literally a JSON file. And the interesting part is the dependencies here. Just like in Laravel, you had that vendor directory, and you had to worry about packages and doing actually updating with artisan or similar commands the libraries you have installed. Similarly, with package.json here, can you manage the libraries and the versions that you care about? So if I have a package.json, I can simply do npm node package manager install. It's going to automatically look at that package.json file, look and see, do I have the latest versions of all of the vendors' modules in a node_modules directory here, or maybe in some parent or ancestor directory. And if not, it's going to download them. And you'll see a whole bunch of HTTP stuff going across the wire. So for instance, let me show you the contents of node modules, just Express. Let me go ahead and boldly delete node modules so that all I have now is this. And if I do npm install, you'll see that it's going to read that package.json file. And we've seen output similar to this in the Laravel world. It's downloading a whole bunch of stuff. And that's because Express, in turn, depends upon a whole bunch of other people's libraries. So all of those are sort of being downloaded recursively. Until now, if I do an ls again, there's my node modules directory back, and Express is back. So it's just a way of simplifying package management. Now if we look at the app.js file, this is going to be a reversion to our earliest web server where we just spit out quote-unquote hello world. But notice the paradigms here. First, we require the Express module. Then we have this line of code, which you know from the documentation. You literally treat that module's variable as a function. So open paren, close paren means execute it. That's going to apparently return something we're going to generally call an app. How it works, I don't really know. I let someone else in the Express world write that. I'm going to now stand on his or her shoulders so as to make my application writing a little simpler. Here I'm going to listen on that particular port, though it could be most anything. And here is code that's maybe more reminiscent now of Laravel and route.php. So this is super simple. I'm just going to specify a route for /star. So everything is going to be absorbed by this request handler. The paradigm for request handlers is it's an anonymous function with a request argument and a response object, just like before. And response.send in Express means you send the code followed by whatever you want to send. And of course, you can do something fancier by actually sending files or HTML or dynamically generated content. But for now, all we did was spit out hello world. If we go into server 3, this is even fancier, just to show you some functionality. And we'll show you an even sexier version of this on Wednesday. But if you've ever heard of Socket.io, maybe? So as I think Jonathan or someone said earlier, one of the things Node is really known for is its real-time behavior. Right? Think about PHP and MySQL. If you were to implement a chat server in PHP whereby two people could open a browser window to foo.com and then start IMing each other, Alice in one window, Bob in another, so that each of them sees his or her messages in the other window. How would you do this in PHP and MySQL? Using or not using Laravel, sort of immaterial. You could have like an index.php file, and you've got to have, in some cases, it's got to spit out a form. So there's going to be an HTML form that probably submits not via normal form submission, but Ajax probably, right? So an onSubmit handler. So you type into a text field, you hit enter, and then it gets sent to the server via Ajax. What do you then do on the server? So you've got index.php or something.php that's received an HTTP parameter from the user, Alice's or Bob's instant message. What do you do with it in order to propagate it to Bob or Alice, respectively? I mean, you literally have the tools with which to do this in your mind. So like, what would you do? You have 1 minute to implement this program. Yeah?
Store for database and then have Alice's side through the database or
Perfect, right? So you've got a database. We know a bit of MySQL. So you have a table that's messages. Maybe there's a timestamp, a user ID, the body of the message itself, created at, updated at, and all of that. So you store it in a database. And suppose Alice sends the first message. How does Bob get that message now from the database?
There might be some Ajax function that's constantly calling back to the database to get new messages.
Exactly. So Bob's code, whose code is the same as Alice's, it's just sort of a symmetric relationship. Bob's browser has some Ajax code that's probably maybe every 30 seconds polling the server via Ajax saying, are there new messages? Are there new messages? Every 30 seconds is going to be kind of suboptimal because he has to wait even if Alice literally just sent the message. So Bob's browser could every second hit the server, but that means Alice's browser is hitting the server every second. What about Charlie and David and Edward and every other letter of the alphabet? What's the problem of this approach? A lot of hits excessively. I mean, you're effectively DOSing your own site, or DDoSing, distributed denial of service attack on your own site, by having all of these users run JavaScript code that's just pinging the heck out of your server, even if, arbitrary number, 80% of the time, no one has said anything in the chat room, but you're just checking to make sure of such. So PHP and a lot of languages are just not good for real-time communications because in PHP, recall, there's no central memory, right? You have session objects, which creates the illusion of central storage, but that's on a per-user basis. You don't have global memory like you do in a Java servlet, if familiar, or in other frameworks like that. Node.js, though, you do have global memory because you have one server, and that can remember anything it wants about all users. And you might still have a database, but the nice thing about Node.js, too, is that it's much better than something like PHP at creating the illusion of handling multiple things at once. And in fact, as an aside, you can implement chat servers in PHP, but you would typically do something called long polling, whereby you don't ping the server every second. You ping the server. The server doesn't respond to you for upwards of 30 seconds. It literally sits in a loop, waiting and waiting, and the server checks if there's new data in the database, and only once it sees, ooh, here's a message from Bob, does it reply to the HTTP server. So the effect in your browser is that the little IE icon or Mozilla or whatever just keeps spinning for 30 seconds at a time, but the upside is you don't have 30 connection requests in 30 seconds, you have one. So it's called long polling. But even better in modern web browsers is something called WebSockets, which if you take in CS143, you can effectively make a TCP connection from a client, like a browser, to a server, and then hang on to it without using nearly as many resources as HTTP might traditionally do. And Socket.io is a Node.js library that makes it much easier to make these socket connections or illusions thereof for old browsers so that you can implement these real-time functionalities. So here's an example. This stuff up top gets a little more complicated, but it's mostly copy and paste from Socket.io's documentation. Here's now a more precise request handler. If the user requests /, what file am I going to apparently serve up to them? Index.html. And there's some new stuff here, stream, which I'll show you in just a moment. But this is just another way of grabbing a file a little more efficiently than just doing fs.read file. It's a little smarter, especially for big files. So long story short, these lines just serve up a file called index.html, which for now assume contains the HTML form via which Alice and Bob might intercommunicate. Lastly, io.sockets.on. So this comes from this line up here. So I'm just reading the documentation. io.sockets gives me access to a so-called web socket with a browser, between the browser and the server. I'm listening for a special event, connection, which means when the user first hits the server, trying to open this connection. I'm going to call this callback, and now I'm going to do the following. Every 5 seconds, what am I going to do? I'm going to emit or broadcast, if you remember Scratch, the graphical language had a broadcast block, so you're going to emit or trigger an event called arbitrarily from server, and it's going to contain a message, ping, and the current date. So this isn't an actual chat server that Alice and Bob can use, but it's sort of an automated chat server where the messages are just sort of sonar pings. It's just date times that are being sent every 5 seconds. So if I actually run this thing, and that's it, to be clear, down here, notice this is just logging down here. So let me turn a blind eye to that. Let me do node of app.js. Let me go to my browser, reload the home page here. And let me close the inspector. Every 5 seconds, I have a demonstration, even though not interactive for humans, of something that's happening asynchronously. In the browser, notice there's no spinning icon. It's using a fancier feature of Chrome and modern browsers of maintaining a socket connection underneath the hood. And it's what's called generally a pub-sub model, publish-subscribe model, where we haven't done that quite explicitly here. But what's nice about this general pub-sub paradigm is that you can have one publisher, in this case the central server, and all of the individual browsers or clients, Alice's and Bob's of the world, can subscribe to it, so you can relay messages among any number of users. And even though, again, we're not seeing interactivity, we had maybe 12 lines of code just to do this. And it's probably not a leap to imagine how you might whip up the index.html file that has a true HTML form, a little bit of jQuery code with Ajax that doesn't send a date time, but just sends whatever Alice or Bob typed to the server, and then the server will relay it out. And I promised to glimpse at one last thing, just to tease you with this. If we go into stream 0 and 1, you'll see code that's just a little different here. Just so you've seen it, this is an alternative to what I called the fs.read file method earlier, whereby you can tell Node.js, go read this file into memory, but if it's big, just give me a chunk at a time. And you might know from CS165 or 161 that file systems have different performance properties. You might want to read in blocks of 512 bytes or 2 kilobytes or whatever. This is an optimized way of getting back a file iteratively so that you can spit it out a little more quickly to the browser or to whoever the end client is. So a huge amount of content today. We're going to dive into more detail on Wednesday with Tim in particular, looking at how we can translate some of the ideas from the first half of the course, Laravel and models, into a library that he himself wrote called bookshelf.js, which has become increasingly popular in the community because it gives you most of, if not more than, the functionality of Eloquent, which, recall, is that library inside of Laravel. So more on that and more how to develop full-fledged apps on Wednesday. We'll see you then.